Hello and welcome to another Pre-Calculus 20 lesson. Today we're going to be looking further at the sine law, so we're going to be examining the ambiguous case, which we have previously done in Foundations 20 last semester. So here's your warm-up. You can go ahead. If you did it, you did it. If you didn't, here are the answers. Make sure you understand how to get these answers, because this type of question will definitely appear on the next exam. Resolving triangles using the sine law. So there you go. So we have a little thing you can hit pause quickly and read through this here. All these scenarios, we can only have one possible triangle, but if we're given angle side side, then we have what's called the ambiguous case, where there could be anywhere from 0 to 2 possible triangles. So let's take a look at these three cases. Scenario 1, given an acute angle A and a side adjacent to that angle, B, and a side opposite the angle, little a. Okay, so we have a triangle. All right, here's an acute triangle. So we have this angle A, 30 degrees. We'll call this angle B, and call this angle C, which means the side A is 5 centimeters long. Side B will be across from B, so this is over here, and this will be 12 centimeters long. And we want to know how long side A needs to be in order to reach the bottom here. The shortest way it can possibly do that is if it went straight down in the shortest possible distance and was perpendicular right there. So we need to see how long this thing needs to be in order to actually reach the bottom, and then decide if A is long enough in order to do that right now. So we want to know opposite, and we know hypotenuse once we've turned this thing into a right triangle with this imaginary line where A could swing to. So what's the minimum length? Now 30, so opposite and hypotenuse, that will be our sine ratio. So we say sine 30 equals opposite, which is the side we want to know, over hypotenuse, which is this B length, 12 centimeters. So we can write A equals 12 sine 30. All right, this is the minimum length A can be in order to reach the bottom here. So go over to your calculator, hit 12 multiplied by sine 30. Make sure your calculator is in degrees, not radians. And the answer is 6. Okay. Please, thank you. So A needs to be 6 centimeters in order to just reach this thing barely. And we're told that A is only 5 centimeters. So in this case, we cannot make a triangle. There is no possible triangle there. Okay, so here's your little rundown of the opposite side. A is less than the product of the adjacent side and the sine of the given angle B, which is written as B sine A. Then you cannot make a triangle. 0 triangle possible. Okay, so let's take a look at this triangle. Construct angle ABC, or triangle ABC, given A equals 30 and B is 12, and A equals B sine A equals 12 sine 30 equals, which we just calculated, which is 6 centimeters. Okay, so this is the scenario where we have the same type of triangle here, and nice. With the same type of triangle here, A and this angle is 30, and B has a side length of 12 centimeters, and we don't know the other ones. C doesn't matter, but we know that A, side A right here, is going to be exactly equal to B sine A, which would give us the very minimum distance. So we basically make our line there, and if this thing was exactly 6, then it would make a perfect right triangle. But if we swung it out this way, it would be short. And if we swung it out this way, it would be short. So the only place it touches is right there. So there's only one possible triangle in this case, because this is the exact value of b sine a. So this gives us one triangle. So what happens if the opposite side a is longer than b sine a? Okay, so side a is longer, so we're going to explore this scenario here. So we have our acute triangle. Again, I'll try to start with something similar that looks, let's shorten this guy a little bit. Okay, that looks more like a 30, so this is a 30 in here. And again, this is angle A, and B has a side length of 12 centimeters. Again, this is side A, and it's going to be 7 centimeters. Angle C, side C, doesn't matter, it's not given to us, so it can be anything we want it to be. So here's the scenario. We already know from our previous calculations that in order to drop straight down, we only require a line of 6 centimeters. Okay, that's what b sine a is, 6 centimeters. Okay, if you've forgotten, you can recalculate this thing. 12 sine 30. So 6 centimeters, but we're told that our a is 7 centimeters, so it's actually a little longer. So it will touch here just on this side of 6 centimeters, and then as you swing it, it will make a little arc and it will touch again here. Because it's actually longer than 6 centimeters, it will extend past the bottom of this intersection. So it swings and then it hits again right here. So whenever A, if given angle A, whenever A is longer than b sine A, we have the case of 2 possible triangles. Okay, so can you all see how we did that?
You see the magic. Got it.
So hopefully you have a better understanding than that guy did. But let's move on. So construct triangle ABC given this information. So we're going to try this. So our angle A is going to be 30 degrees again, so let's make a big triangle here. Call this 30 degrees. Now, of course, I'm not making my triangles perfectly to scale. It does help if you do. So this is 12 centimeters. Now, b sine A, and I'm going to adjust this triangle a little bit to make this more realistic, because we're told that this side is 14 centimeters, so it has to be longer than this one right here. Okay, so A is long, and we know that we only need 6 centimeters to get down here. Well, let's see what happens here. If C can be any length, this short side, or this long side, small c, okay, then we can make a triangle way out here like this, make a really large triangle with this side being really long. We take this arm now, and we try to swing it over, and it'll go way down here like this, and then it'll come up here like this, and it's too long to hit this baseline again, because it's longer than side B. So we have a scenario where we can again only make one triangle. So this is the 4th possible case, and this is only one possible triangle. Okay, when this is longer than B, then you can't swing it and make a second triangle, so it will no longer give you 2 possibilities. So here's your summary. So if in ABC we're given an acute angle, so less than 90 degrees, angle A, a side adjacent, which is side B, and a side opposite, which is side A. So this is the ASS case. If A is less than B sine A, 0 triangles can be drawn. If A equals B sine A, then 1 triangle can be drawn, and it's a right triangle. So 1 right triangle, and that's it. If A is greater than B sine A, but still smaller than B, then 2 triangles can be drawn. So A is smaller than B, so when we swing it, we can still make a second triangle. Now, if A is greater than B sine A and greater than or equal to B, then only 1 triangle can be drawn, because when we swing that arm, it's going to extend past where B hits. Okay? So let's get a little practice here. How many triangles ABC can be formed in this case? A is 20, B is 5, and A is 3. So let's figure this out. B sine A. So B sine A is 5 sine 20. Okay, so I'll just remind you that this is B sine A, not 6 sine A, B sine A. Okay, pretty bad, pretty ugly. So let's calculate this. 5 times sine 20, and we get 1.71. Okay, so 1.71. Now, A is longer than 1.71, so this will reach to the bottom. We only needed it to be 1.71 in order to make a right triangle, but it's plenty long, but it's still less than B. So when we take it, and we take this arm that is longer than this, so it'll attach here, and then we swing it over, it'll hit somewhere again over here, and we can make a second triangle because 3 is less than 5. So this one would be 5, and this one would be 3. So here there are 2 possible triangles. How many triangles can be drawn in this case? Now, all they've done is change the letters that we use. So we still have L and its opposite side. Okay, so let's figure this out. This will be M sine L. So M sine L is equivalent to B sine A. And this will be 13.25 sine 34. And I think you're going to see why we chose these numbers. 13.25 sine 34. 13.25 times sine 34. So this is the shortest the other side can possibly be to make a single right triangle, 7.41. Okay, so this answer is 7.41. Now it just so happens that L has the exact side length of 7.41, which means it just barely reaches the bottom, which means it can only make 1 triangle, and of course it will be a right triangle. How many triangles QRS can be drawn? Same situation, do the same old test. So let's go R sine Q, so 9.35 sine 72 degrees equals 9.35 sine 72, and we get 8.89. So we'll go 8.89. Did you forget how to make an 8 doll? And Q is 10.36. So here is our situation. We have this angle 72 degrees, which I haven't drawn it even close to that. And we have this side 10.36. Now, this side is 9.35. So we can make a triangle because we only needed 8.89 for it to reach here. So it'll make a triangle here. But if we swing it, it's actually longer than this side. So when we swing this thing over, it can't make a second triangle. So there is only 1 possible triangle in this case. Finally, our last one here. How many triangles DEF can be drawn? And same situation. Let's go E sine D. So 5.67 sine 60 equals 5.67 sine 60. and we get 4.91. This is 4.91. And D, the opposite side, is long enough to get down there, okay? But it is still shorter than E. So when we swing it out, it won't extend past E like we did in this situation. We'd swing it and it would touch again somewhere in here and it would make a second triangle. So in this case, there are two possible triangles. That's all we're going to do for today. So I will see you in class probably in a few minutes, or tomorrow if you actually did your homework and watched the video.